Okay, so the next test, next example we're going to use is when we have non-normal data and our n's are relatively small, and we'll show what do we do. And if our data is not normally distributed, we cannot run a t-test when our n's are less than 30 per group. So we have to find an alternative, and what we will use is a non-parametric test. And a parametric test is one like the t-test where we have parameters. We have a means and we have a variance and standard deviation. With non-parametric tests like the chi-square, we typically use counts or we use ranks, how people rank relative to each other. And the Mann Whitney test is a non-parametric test that's the non-parametric equivalent of the independent group's t-test. So if your data is not normally distributed and your sample size is relatively small, then you will use the Mann Whitney test. Okay. So the example I have is I have two stellar Ivy League institutions, the Matchadash College and the Fesserton Institute of Technology, two very elite academic institutions. Both of them have a number of Nobel Prize winning researchers on their faculty, and they both send a lot of people to the top colleges to complete their graduate studies. And for admission into a graduate program, oftentimes students are required to complete the SAT version for grad studies, which is the Graduate Record Exam, or GRE. And I want to see if there's a difference between the two groups in terms of their performance on the Graduate Record Exam. So do Matchadash students and Fesserton students differ, right? So it's a difference. It would be a two-tailed test. Okay. And I collect my data. I do have unequal n's, so they are small, less than 30. And I gotta now go through my diagnostics. And the first diagnostic I'll do is my test for normality. So I have 1, 2, 3, 4, 5 Matchadash students, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 Fesserton students. Okay. So what I'll do is I'll have the data in SPSS, which you have available to you on Blackboard. So I will do my diagnostics, which analyze, descriptives, explore. My dependent variable is GRE, and school is my factor list, and I go OK. Okay, so that's just going to be doing my diagnostics. Okay, so first I'm going to look at my skewness measure, and I see that for my 5 Matchadash students, their skewness indicator is a value as a metric is 2.15. The standard error is 0.9. If my skewness measure of 2.151 is more than 2 times the standard error, so if I take 0.913 and times it by 2, I'm basically getting roughly about 1.8 something. 2.1 is much greater than that. So my data looks to be skewed. My Fesserton data looks okay. So the one group is the distribution is relatively normal. The other group is highly skewed. Now I will go to my box and whisker plot, and voila. I have an outlier here. So I have record 5 in my data, has a GRE score of 800, and it is more than 1.5 times the interquartile range above the median. It's an outlier, and that's what's driving my non-normality. My Fesserton data is slightly skewed, negatively skewed. I can see here, if everything was right, the median value would be right halfway, would divide this box in half. But it's up at the top, and there's a stretch to this box on the downward way, which would mean, and my whisker is a bit longer on the lower end than the top end. So not much real estate here, slightly shorter bar here than here, and a lot of real estate. So I got a stretch, a slightly negative skew to my Fesserton. My Matchadash data is a train wreck. I've got an outlier, which is record 5 at a GRE score of 800. And if I look at that, if I go to record 5, there it is. Person 5, record 5, there's a score of 800, which is well above the other scores for Matchadashi. Okay, so my data is not normal. My data is not normally distributed. I have to stop here. I can't run a t-test. So the t-test is not the way to go. My alternative is the Mann Whitney test. So once I've figured out that my data is not normally distributed, I can't run the t-test for my small n's less than 30. I then go to the Mann Whitney. The Mann Whitney is actually really easy to calculate. You're not going to have to do it by hand, but if you wanted to, you can have some fun. It's more of a manual calculation. Okay, so what I do is I rank order the data. So I take the data and I rank order it from the lowest GRE score to the highest. And I take into consideration what group is which, right? So here are the lowest ranking to the highest ranking. Now I can see here in the data that the Match-A-Dash people tend to rank very highly relative to the Festerton. Most of the scores that are low, almost all of the lower scores are all Festerton. So in terms of ranking, the Match-A-Dash students rank higher than the Festerton, and that's what I want to see at is the average rank for Match-A-Dash greater than the average rank for Festerton. And here's the rank order. Okay, so the calculation for the Mann Whitney is really straightforward. That slide's really dumb, and it's two-tailed. There's a tendency for the ranks in one group to be systematically higher than in the other group. There is no difference. There is a difference. One group tends to rank higher than the other. I can see here that the Match-A-Dash seem to rank higher than the Festertons. Okay, so the grunt calculation here. So what I do is I go to every Match-A-Dash person in terms of their rank order, and I ask myself, how many Festerton students rank higher than that given student? So for the student who had a GRE, the Match-A-Dash student had a GRE of 520. There are 2 Festerton students who ranked higher than that student. So I put in a 2 here beside that person's on that person's row. I go down to the next person. They had a score of 530. They rank 10th. There are 2 Festertons that are higher than them, a score of 2. I go through this cluster of 4 people, and there are 2 Festertons that score higher. Then the last Match-A-Dash student, there are no Festerton people who score higher. So I put in a 0. And then this is referred to as my UA. And then what I do is I add up these values. So 2, 4, 6, 8. So the value for the rankings, the number of rankings where of Festerton higher than Match-A-Dash is 8. I then go and complete that for the Festertons. So for each of the Festertons, how many Match-A-Dash rank higher than each Festerton person? So all these people here ranked 1 through 8. There are 1, 2, 3, 4, 5 Match-A-Dash higher. So I put in a 5 here, and I do that for all of them. And then for the 2 highest Festertons, ranked 13 and 14th, there's the one Match-A-Dash who ranks higher than them. And I enter in a 1 here for both of those. Then I sum those values up, and it sums up to 42. So UA is the one for the Festerton higher than Match-A-Dash, which there aren't that many. And then Match-A-Dash higher than Festerton. There's a lot. Well, there's not that. That's almost all the Match-A-Dash people. Okay. Then what I do is, this is a very grunt calculation. I'm not going to force you to do it by hand. I have UA. I take the lower of the 2 values. So UA is for the Match-A-Dash, how many Festerton are higher than Match-A-Dash. And then for the Festerton, how many Match-A-Dash are higher than them. I take the lower of those 2 values. So my statistic is based upon the 8. And then I go to my Mann Whitney table on Blackboard, which we have here. I have the stats tables. So I find the Mann Whitney table, which you have on Blackboard. And I have, for N1, I have 5 people. So I have my 5 Match-A-Dash. And then I have my 10 Festertons, like I find the 10 for N2. And for alpha equal to 0.05, to reject the null hypothesis, my lower value, my UA, which is 8, to reject the null hypothesis, that value has to be less than or equal to 8. And it actually is less than or equal to 8, and I therefore reject the null hypothesis. Okay. To run that in SPSS, I go to Analyze, Non-Parametric, Legacy Dialogues, and I pick Independent Samples. And then my test variable is their GRE score, and the grouping variable is school. I have them coded as a 1 and 2. So I have to code them in properly as a 1 and 2. I get my test statistic, and it gives me I don't have to write the mean rank, but the match rank higher than the Festertons. And the Mann Whitney score is 8, and the significance two-tailed. Not I always pick A because it corrects for any ties. Ties get a little wonky, so we don't have any tie values. So my two-tailed significance is 0.037. I reject the null and conclude that the match students basically outranked the Festerton students. Now to do this in SPSS, I'll just walk through, analyze, non-parametric. I use the legacy because I'm a geriatric. 2 independent samples. School is my grouping variable. Right click, and it's a 1 and a 2, so define the groups. 1 and a 2, continue. Test variable is the GRE. I want the Mann Whitney test. Don't worry about the other ones. And voila, that replicates what we had. Mann Whitney U, I used the lower one, which is the 8. And there's my significance two-tailed, which factors in for ties, 0.037, which I don't have any anyway. And I would then conclude that I reject the null hypothesis based on the Mann Whitney test. The match students outranked the Festerton. I would not run a t-test.